Number 14, is the self-ionization of water endothermic or exothermic? The ionization constant for water, Kw, is 2.9 times 10 to the negative 14th at 40 degrees Celsius, and then it's 9.3 times 10 to the negative 14th at 60 degrees Celsius. Okie dokie. So, we're talking about ionization of a certain molecule, right? And they give me Kw values. Now, last chapter, I believe, chapter 13, we went in depth about K values, capital K, right? And remember, a K value, any K, capital K, could be Kc, we saw that last chapter, Kp, we saw that last chapter, but now we're going to start seeing more K values. In this one, it's Kw. And Kw, the W stands for water. So Kw is specific for only water. And in this case, water is ionizing, which basically means that it's splitting up. So if I just write H2O, right, and this is in equilibrium, right, between two different ions, it's breaking apart. But you might have seen this in some cases, especially when we did the balancing chapter together. And sometimes when I look at H2O, I say, okay, I'm going to rearrange this, because what water basically is it's an H plus ion and an OH ion. Those are your two different components inside of water. The split is right here if we needed to break this up. And that's exactly what we're going to be doing. But do you see how there's two hydrogens here and one oxygen? But the split is this way. It's not just H's and O's. It's hydronium and hydroxide. So this will split up into H plus OH minus. Something that's super important to remember, guys. I'm just going to put this maybe up top here. Okay. And since these are charged, that means that they are aqueous. So aqueous and aqueous. Anytime that you see a charged ion, that's always going to be an aqueous. But remember, water is the liquid. So this is an L. Now, when we write the Kw formula, remember, K values are generally equal to products divided by reactants, right? And it's raised to those coefficients. So it's the same idea here. We're looking at the products first. Now, in this case, there's two products. They're both aqueous, so they're allowed to be in the equation. So this would be the concentration of H plus times the concentration of OH minus. Now, we're going to be using this a lot in the upcoming section, so I would just memorize it. Now, this is technically divided by the reactants, but remember, no liquids allowed in any K equation. So I'm not going to include the water. This would just be over 1, and anything over 1 is itself. So this is the formula that we're going to be using a lot in the next chapter. Not the next chapter, the next section. So I would definitely just remember this. Okay, guys? All right, so now we're going to use this to figure out what's going on. Well, they gave us two types of scenarios here. They told us that we had a Kw, so maybe I'll just write that. Maybe I'll write that over here. We have a Kw equal to 2.9 times 10 to the negative 14th, and this was at 40 degrees Celsius. And then they told us that we had a Kw equaled 9.3 times 10 to the negative 14th at 60 degrees Celsius. Okay. So now, what happened to the Kw values as the temperature increased? As the temp increased, what was going on with the K values? Did it increase or did it decrease? Yeah, it increased, right? So as temperature increased, the Kw values also increased. And remember, a larger Kw value means that you're favoring more products, right? The bigger and bigger and bigger the Kw value are, the more you're going to be favoring the product side at equilibrium. So maybe I'll write that down. So as you're increasing, you're favoring the product side. So you're making more products as the temperature is increasing. Now we just have to put a word to it. Is this endothermic or is this exothermic? Well, as temp is increasing, we are favoring this side. This is going back to Le Chatelier's principle, right? And what's going on here? We're focusing on increasing temperature because we're going from 40 to 60. So as you're increasing temperature, you're always going to be going away from the heat. Now, if we know that we're making more of this side, right? If we know that we're making more of the product side, that means we're favoring this side. So, in terms of where the actual temperature is, where this heat is, if you're increasing the temperature, you're going away from the heat. So, the question is the heat word on this side of the equation, or is the heat word on this side of the equation? If we're going this way, we have to go away from the heat. I'm going to the right, which means that the heat should be on the left. If I'm going this way, the heat can't be on the same, because when you're increasing temperature, you go away from the heat. So by doing this little thing, we're favoring more products. The heat has to be on the left side. So I'm just going to get rid of this. And now, this is now all like, multiple chapters coming together. If your heat is on your reactant side, is that endothermic or is that exothermic? This was in your enthalpy chapter. Since the heat is on the reactant side, that is endothermic. Endo. But if we found out that the heat was on the product side, that would be classified as exothermic. So since the heat is on the reactant side, it is endothermic. And maybe I'll just put that over here, just to kind of make it more easy to see. And that's all the question was asking, right? Is the self-ionization of water endo or exo? It's endothermic. And we found that out because we just understood what was going on with increasing temperature. Kw was increasing, we shift to the product side, and the heat has to be on the other side. And that's it. Hopefully this helps. Thank you so much. Let me know in the comments. Subscribe to the channel. That will help us out. And I really hope we're giving you great educational content. If you want to check the channel out, we also have physics and math videos at the moment. But we got something in store. It's coming up. It's going to be crazy. All right? And I think you guys will like it. All right? But we're working hard. All right? So let's work hard. And I'll see you later. Okay, bye-bye.